Welcome to Navy Builder Knowledge. In this video we will be covering everything you need to know for wall and ceiling framing. You will be able to use this knowledge for your advancement exam. So if you're ready, let's get started. Please be sure to click the subscribe button and hit the like button and the bell, and you won't miss any of our knowledge videos. Let's start out with wall and ceiling framing components. First is the plates. The plates are horizontal members that tie the studs together at the top plate, and the bottom plate or the sole plate of a wall. They furnish support for the lower ends of the rafters and ceiling joists. They also serve as a shoe at the bottom end of the studs. On exterior walls, the top plate is doubled to interlock all corners, help straighten the walls, and give added strength to carry the ceiling joists and rafters. Next, let's cover studs. There are different names and purposes for studs. The common studs run from sole plate, also known as the bottom plate, to the top plate. The trimmer studs actually are used to trim all door and window openings. The cripple studs are studs placed below a window sill or above a header. And last are the king studs. Then we have the corner posts. They are constructed wherever a wall ties into another wall. Outside corners are at the ends of a wall. Inside corners are where a partition ties into a wall at a point between the ends of the wall. There are three typical designs. 1. Outside corner construction using only 3 studs. 2. Outside corner construction using 2 studs with short blocks between them at the center and ends. 3. Inside corner construction using a block laid flat. A full-length stud can be used instead of a block. Headers. A header is a horizontal structural member placed over the top of a wall opening. It distributes the load to either side of the opening. The type and size of header required is shown in the blueprints. Various methods are used to construct door and window headers. In other words, you may need to laminate a piece of 1/2 inch plywood to ensure you will have full bearing on studs. For 2x4 walls, you'll need solid 2-inch thick pieces with spacer. 2-inch thick pieces with 2x4-inch base. Insulated header. For 2x6 walls, solid 2-inch thick pieces with 2x6-inch base. Insulated header. Rough door and window openings. These openings must be framed into a wall wherever a door or window is planned. The rough opening for a door is framed with a header, trimmer studs, and, in some cases, top cripple studs. The rough opening for a typical window includes the same members as for a door, plus a rough window sill and bottom cripples. The tops of door and window openings in walls are usually in line with each other. Rough window openings have a rough sill at the bottom. The sill provides support for the finished window. The distance between the sill and the header is determined by the dimensions of the window. Fire stops. Fire stops are required by most local building codes in walls over 8 feet, 1 inch high. They slow down fire, smoke, and toxic fumes from traveling room to room or floor to floor. They are made from a variety of material. Wall bracing. Bracing is used to stiffen framed construction and make it rigid in order to resist winds, storms, or twist and strain from any cause. It keeps corners square and plumb and prevents warping, sagging, and shifting from lateral forces that can distort the frame and cause badly fitting doors and cracking plaster. Lead-in bracing. Lead-in bracing is usually made from 1 inch by 4 inch material, set diagonally from top plates to sole plates. For lead-in bracing, the studs are notched so that the brace will fit flat and flush with the surface of the studs. The studs are always cut to let in the braces are never cut. Cut-in bracing. Cut-in bracing is usually made from 2 inch by 4 inch material. It is toe-nailed between studs and inserted in diagonal progression between studs at a diagonal from the top of a corner post to the sole plate. Plywood sheathing. Yes, plywood sheathing is used to brace the walls also. It has the highest strength out of all bracing. Each board acts as a brace of the wall. Other types of bracing may not be necessary if plywood sheathing is more than half an inch thick. Diagonal metal bracing. Diagonal metal bracing comes in 3 different shapes: flat, T-shaped, and L-shaped. The flat will lay flat from the top plate over the studs to the bottom plate. For the T and the L shapes, a part of that bracing must go into the studs. Lay out the bracing where you want it to go and draw a line on the structure, and then come back with a circular saw, cut into the wood, and then place bracing into the wood. Only place nail in the top plate and bottom plate. Now let's begin with the ceiling framing components. Starting with the joists. Joists are the most important framing members of the ceiling. The size, spacing, and direction of travel are given on the floor framing plan. They are usually spaced at 16 inches or 24 inches on center. They will usually all run in the same direction, but plans sometimes call for different sets of joists to run at right angles to each other. Ceiling joists should run in the same direction as roof rafters when possible. Next is stub joists. Stub joists are short joists running at right angles from a regular joist to an outside wall. They are necessary when rafters and ceiling joists do not run in the same direction. Rib bands. Ribbons are used when you have ceiling joists that do not require header. When you don't have a header, joists may twist or bow at the center of their span. A rib band is nailed at the center of the spans to prevent twisting or bowing. Strong backs. Strong backs are more effective than rib bands for preventing ceiling twisting, bowing, or sagging. They are built with 2-inch by 6-inch or 2-inch by 8-inch material, nailed to the side of a piece of 2-inch by 4-inch material. Then are blocked up and supported over the exterior walls and interior partitions. They hold the ceiling joists in alignment and help support joists at the centers of their spans. Let's check out the different wall framing techniques. There are 2 different techniques. The first one is the horizontal plate layout. This procedure for framing is where chalk lines are snapped on the subfloor and all framing members are marked, and allows for error-free framing, just like Larry Hahn does it. The second way is the vertical layout. You will calculate the lengths of the different vertical members of a wood-framed wall using sectional views from the blueprints. Makes it possible to pre-cut all studs, trimmers, and cripples required for a building. But as builders, when has anything been so perfect that you can go off of the plans? Now we will cover the material estimating process. Starting with the plates. We will check the prints for number of plates required. They are measured in lineal feet from the floor plans. This needs to include the sole plate, the top plate, and the double top plate. Next will be the studs. You will determine stud length from prints, usually the sectional view. Then use appropriate formula for determining the stud quantity. For 12 inches on center, take the building length times 1 and add 2 for each opening. For 16 inches on center, take the building length times 0.75 and add 2 for each opening. For 24 inches on center, take the building length times 0.5 and add 2 for each opening. And now for sheathing. You will need to determine the total square footage of the wall area requiring coverage. Then determine total square footage of all openings, and subtract from total square footage requiring coverage. Then add 10% for waste. Since we are talking about sheathing, let's talk about the sheathing fastener requirements. Nails must be 6D for 1/2 inch or less thickness, 8D for thicker than 1/2 inch. Screws must be 2-inch for 1/2 inch or less thickness, 2.5 inches for material thicker than 1/2 inch. Staples, if you are going to use staples, they must be 1 1/4 inch minimum length. We went over the basics on horizontal plate layout. It's time to get more in depth. You will begin by snapping chalk lines on the subfloor to indicate the exact locations of your walls. Reminder, wall locations are determined by the measurements provided on the floor plan. You will cut the top and bottom plates to length and tack them to the lines. You will mark plates for corner posts and regular studs, as well as trimmer studs and cripple studs for rough openings. Lay out studs for the first exterior wall. For walls laid out to be 16-inch on center, mark the plates for the first stud from a corner post by measuring. This should be 15¼ inches from the end. Subsequent studs will follow the 16-inch on center layout. Lay out cripple studs to follow the stud layout. Now that the first wall is marked out, we can lay out studs for the second exterior wall. You will mark the plates for the first stud to be placed 15¼ inches from the outside edge of the panel on the first wall. This layout allows the corner of the first panel on the second wall to align with the edge of the first panel on the first wall. Next, we will lay out the studs for partitions or partition walls. If wall panels are placed on the exterior wall before the partitions, mark the wall plates for the partition for the first stud to be placed 15¼ inches from the edge of the panel on the exterior wall. If the panels are to be placed on the partitions before they are placed on the exterior wall, mark the wall plates of the interior wall for the first stud to be placed 15¼ inches from the unpaneled exterior wall. Rough door and window openings. Mark on the wall plates the dimensions for the widths of rough door and window openings. Rough openings are calculated based on door or window width, finish frame thickness, and a 1/2-inch shim clearance at the sides of the frame. Door and window schedules on prints may provide rough opening dimensions. You must calculate the rough openings if the schedules do not include them. Wall assembly and erection. First, we will construct the corner posts. All corner assemblies should be constructed from straight stud material and should be well nailed. For improved productivity, corner posts for a building are commonly assembled prior to wood-framed walls being assembled and may all be constructed at one time using a bench. Blocks should be held slightly back from the ends of the studs. Before nailing, ensure the ends of the studs align with each other. When framing corners, use full-length studs or short blocks. Now let's go over the corner posts. Outside corner posts are placed at the outside corners and are at ends of a wall. Outside corner posts are constructed of 3 full-length studs, provide room for insulation to be placed between the corner studs and exterior wall sheathing. Nail flat blocks into the first stud using 2 16D nails in each block. Nail the second stud into the block using 2 16D nails in each block. Now for inside corner posts. Inside corners occur where a partition ties into a wall at some point between the ends of the wall. Toenail the block set on edge using 2 8D nails in each block. Nail the second stud into the blocks using 2 16D nails in each block. Now it's time to assemble door and window openings. Starting with the door opening assembly. Select 2 precut wall studs and lay them on the subfloor. Nail the trimmer stud to the wall stud using 16D nails staggered 16 inches on center. Place a header between the wall studs and on top of the trimmer studs. Toenail the cripple studs into the header using 4 8D nails, 2 on each side. And now the window opening assembly. Follow the same steps for assembling a door opening. Add a rough sill and bottom cripple studs. Cripple studs follow the stud layout. Usually 16 inches on center. Now we have all of the pieces ready to be placed. Nail the entire wall together while it lies on the subfloor. Position the top and bottom plates on the subfloor at a distance slightly greater than the length of the studs. Position the corner posts and rough openings between the plates according to the plate layout. Place the studs in position with the crown side up and nail the plates into the studs, cripple studs, and trimmer studs. Reminder, on long walls, breaks in the plates should occur over a stud or over the header. Now we can place the double top plates. The top plate can be doubled while the wall is lying flat on the subfloor or after all walls have been raised. Nail the topmost plates so that they overlap the plates below them at all corners. Fasten the top plate ends with two 16D nails. Between the ends, place 16D nails, every 16 inches on center, to more easily identify stud locations when sheathing the wall. But joints between the topmost plates should be at least 4 feet away from any but joints in the plates below them. Square the framed wall. Position the wall so that the bottom plate is next to the chalk line that shows where the wall will be fastened. Tack a few blocks at one side of the line. Push the wall against the blocks, and at each block, tack the bottom plate to the subfloor. Using two tape measures, measure diagonally across opposite corners. When the two measurements are equal, the wall is square. Now we can install the let-in bracing. Mark the plates and studs and notch them for the brace. Tack the brace to the studs while the wall is lying on the subfloor. Reminder: tacking instead of nailing allows for some adjustment after the wall is raised. After any necessary adjustments are made, the nails can be securely driven in. Now you can place the fire blocking in the wall. Raising the wall. Now that the wall is ready, it's time to raise it up. The rule of thumb for raising a wall is, one person is required for every 10 feet of wall. Order may vary from job to job, but usually, longer exterior walls are raised first. Then shorter walls are raised and the corner posts nailed together. The order of framing and raising interior partitions depends on the floor layout. Securely fasten the wall's bottom plates to the floor after raising it. For walls resting on a wood subfloor and joists, drive nails through the bottom plate, subfloor, and into the floor joists. Now it's time to plumb and align the wall. Plumb outside corners first and securely brace them for safety. Align and straighten the wall tops after all the corners are plumbed, but before nailing floor or ceiling joists to the tops of the walls. Fasten a temporary brace to a wall stud at each checkpoint. Do not remove the temporary braces until the framing and sheathing for the entire building is complete. Once completed, we are now ready for plywood sheathing. Ensure the first panel is plumb along the vertical edge and level along the horizontal edge. Secure the panel with nails, screws, or staples at the corners. Snap vertical chalk lines to mark the location of intermediate studs before installing nails or screws. Ceiling layout and installation. For the layout, you will place ceiling joists directly above wall studs when joist and stud spacing are the same. Most building codes do not require ceiling joists to align with studs in buildings with double top plates. Joists placed directly above studs will follow the same layout as the studs below. If joist and stud spacing are different, for example, if joists are spaced 24 inches on center, over 16-inch on center studs, lay out the first joist at 23¼ inches on center from the outside of the wall, then at every 24 inches on center thereafter. Mark the positions of the roof rafters as the ceiling joists are being laid out. If ceiling joist and roof rafter spacing are the same, there will be a rafter next to every joist. If ceiling joists are spaced 16 inches on center and rafters are spaced 24 inches on center, then only every other rafter will be placed next to a ceiling joist. Cutting and installing ceiling joists. Cut ceiling joists to length before placing them on top of the walls. Mark X's to the right of lines on the double top plate at the near exterior wall. Mark X's to the left of lines on the far exterior wall. Ceiling joists lap over the interior bearing partition. Install ceiling joists on one side of the building. Toenail the ends of the joists into the double top plate with 3 8D nails. Drive in 2 nails on one side and the third nail on the opposite side. Now install ceiling joists on the other side of the building. Fasten the outside ends to the double top plate with 8D nails. Toenail the lapped ends with two 8D nails, then fasten the lapped ends to each other with three 16D nails. Place backing on the walls running parallel to the joists. Nail the backing in with 16D nails at 16 inches on center. Install blocks flat between the joists where needed to fasten the tops of the interior walls running parallel to the joists. Place the blocks at 32 inches on center. Drive two 16D nails through the joists into each end of the block. Then drive two 16D nails into the top of the backing. Cut out and frame the attic scuttle. Reminder, if the attic scuttle is greater than 3 square feet, the headers and joists must be doubled. Place strong backs at the center of the spans. Nail the strong back to the edge of a 2-inch by 4-inch board with 16D nails at 16 inches on center. Then drive two 16D nails through the 2-inch by 4-inch board into the top of each joist. Ceiling frame material estimating process. Determine joist length and direction from blueprints. Joists placed directly above studs, 16 inches on center. The number of joists equals 0.75 times the building length plus 1. Joists not placed directly above studs, 24 inches on center. The number of joists equals 0.5 times the building length plus 1. We hope you gained some knowledge today with this video. Be sure to hit the like and subscribe buttons if you would like to see more. Have a great builder day. And good luck on your exam.